Hi everybody. In this video, we are going to find orthogonal and orthonormal vectors using Gram-Schmidt process. And we are going to do QR factorization. First of all, what do we mean by orthogonal and orthonormal vectors? Orthogonal vectors are the vectors which are perpendicular to each other. So they create 90 degrees between each other. And their dot product is 0. Here we are going to find three vectors which are perpendicular to each other on the horizontal axis, on the vertical axis, and the third vector will be coming out of the screen, like the 3D here. And they will be all 90 degrees to each other. So what is orthonormal vector? Orthonormal vectors are orthogonal, but their length is 1 unit. Okay, we're going to find three orthogonal vectors u1, u2, and u3 given by these formulas. We were given three columns in the original question. Let A be vector 1, let B be vector 2, and let C be vector 3. u1, which is our first orthogonal vector, is actually v1, which is the first column. That was easy. That is 1, -1, 0. So our first orthogonal vector is 1, -1, 0. Our second orthogonal vector u2 is given by this formula, v2 minus u1 dot v2 over u1 dot u1 dot u1. Let's place them all. As long as you label them very well and place them correctly, you have no chance to make mistake. v2 is our second column, 2, 0, -2, minus, we're going to dot u1 by v2. u1 is our first orthogonal vector, 1, -1, 0, and v2 is our second column, 2, 0, -2. And we're going to dot u1 by itself in the denominator, and we're going to multiply everything by u1. So let's do the dot product here on the side. 1 times 2 is 2, plus -1 times 0 is 0, plus 0 times 2 is 0. So we find here 2, we're going to place it. 1 times 1 is 1, plus -1 times -1 is +1, plus 0 times 0 is 0. So we find 2 on the numerator, and we find 2 on the denominator, so division will be 1. And scale factor 1 will not affect this vector. So technically, 2, 0, -2 minus 1, -1, 0 is our u2. 2 minus 1 is 1, 0 minus -1 is +1, and -2 minus 0 is -2. So this is our second orthogonal vector, u2. This is our u2. Let's place it in our table as well. 1, 1, -2. Now we're going to find the third orthogonal vector, u3. And if you would like to check if they are orthogonal to each other or not, you're going to do dot product here. So 1 times 1 is 1, plus -1 times 1 is -1, plus 0 times -2 is 0. So if you add them up, 1 minus 1 is 0. If their dot product is 0, then check is correct. u3 is given by this formula. V3, which is the third column, minus U1s here, which is the first orthogonal vector. Let's place them all first. And V3, which is the third column, 3, negative 3, 3. Minus, we have U2s here, which is the second orthogonal vector we found. Let's place them all. And we have V3 here, which is the third column again. And we can also place actually V3. V3 is what? V3 is the third column, which is 3, negative 3, 3. Let's do the dot products and clean up. 1 times 3 is 3. Negative 1 times negative 3 is positive 3. Plus 0 times 3 is 0. So 1 times 1 is 1. Plus negative 1 times negative 1 is positive 1. Plus 0 times 0 is 0. So we finished this dot product. Let's do this one. 1 times 3 is 3. 1 times negative 3 is negative 3. And negative 2 times 3 is negative 6. 1 times 1 is 1, plus 1 times 1 is 1, plus negative 2 times negative 2 is positive 4. Okay, now let's clean up. 3, negative 3, 3 is our V3 here, minus our dot product is here 6 over 2, which is 6 over 2 is 3, times this vector, minus we have 3 cancels 3, negative 6 divided by positive 6, which is negative 1, times this vector. Okay, let's clean up a little bit more. We have first vector 3, negative 3, 3, minus, let's multiply by the scale factor, this vector. So what we're going to get is 3 times 1 is 3, 3 times negative 1 is negative 3, 3 times 0 is 0. Minus, we're going to multiply this vector by this scale factor. So negative 1 times 1 is negative 1, negative 1 times 1 is negative 1, and negative 1 times negative 2 is 2. Now we're going to add component by component. So 3 minus 3 is 0, minus 1 is positive 1. Negative 3 minus 3 is negative 3 plus 3, which is 0, minus 1 is positive 1. And 3 minus 0 is 3, minus 2 is 1. So our third orthogonal vector is 1, 1, 1. This is our U3. So let's place it to 1, 1, 1. Now we're going to find 3 orthonormal vectors which has length 1, Q1, Q2, Q3 by dividing each orthogonal vector by its length. So our Q1 is given by U1 over magnitude of U1. And Q2 will be U2 over magnitude of U2, or length of U2. Q3 will be given by U3 over length of U3. Now we're going to find orthonormal vectors Q1, Q2, and Q3 by dividing each orthogonal vectors by their magnitude. Let's start with Q1. Q1 is given by u1 divided by its magnitude. Our first orthogonal vector u1 was 1, negative 1, 0, divided by its magnitude. Each component squared and added. So 1, negative 1, 0, divided by square root of 2. Each component divided by square root of 2 will give us q1. So 1 divided by square root of 2 negative 1 divided by square root of 2 and 0 divided by square root of 2. This is our first orthonormal vector, q1. Our q2 is given by u2 divided by its magnitude or its length. Our u2 was 1, 1, negative 2 divided by its length, 1 squared plus 1 squared plus negative 2 squared. 1 squared is 1, 1 squared is 1, negative 2 squared is 4, altogether square root of 6. Each component divided by square root of 6 will give us q2. 1 divided by square root of 6, 1 divided by square root of 6, negative 2 squared divided by square root of 6. This is our q2. And finally, our q3, which is the third orthonormal vector, is given by u3 divided by length of u3. Our third orthogonal vector was 1, 1, 1. And the magnitude is square root of 3. Each component divided by square root of 3 is our q3. So this is our q3. Now we found our three orthonormal vectors and we can make up our matrix Q. So 1 divided by square root of 2, negative 1 divided by square root of 2, and 0. We can draw this later. And our second column is 1 over square root of 6, negative 1 over square root of 6, and negative 2 over square root of 6. And our third column is 1 over square root of 3. This is our matrix Q. And our QR factorization, A equals to Q times R. A is our original matrix made up by the given three columns, which is 1, negative 1, 0, 2, 0, negative 2, 3, negative 3, and 3. This is our matrix A. Our Q is the orthonormal vector. So this is, let me copy from here real quick. If you want, you can rationalize all denominators or leave it in this form, depending on your aim. And matrix R is the upper triangular matrix, which gives us matrix A if we multiply by matrix Q. And R is found by transpose Q times A, matrix A. Q transpose multiplied by A will give us R, which is upper triangular matrix. So let's write down Q transpose. The first column will be the first row. 1 over square root of 2, 1 over square root of 2, negative 0. 1 over radical 6, 1 over radical 6, negative, and negative 2 over radical 6. And the third column will be the third row. 1 over root 3, 1 over root 3, 1 over root 3, multiplied by matrix A. This is the easiest part of the QR factorization. This is just simply matrix multiplication. And I did it on the side. So what you're gonna get is radical 2, 0, 0, radical 2, radical 6, 0, 3 root 2, negative root 6, and root 3. So we obtain our upper triangular matrix R by QR factorization. So let's sum up. We started with 3 columns given. And using these 3 columns, we found our orthogonal vectors, which are perpendicular to each other. Then we divided each orthogonal vectors by its magnitude to find our orthonormal vectors, which has length 1. And we make our matrix Q with this Q1, Q2, and Q3 orthonormal vectors. And our matrix A is built by the first given columns. And matrix A is given by Q times R. R is the upper triangular matrix. Or you can find R by Q transpose times A. That's it for this video. See you at the next question.